AgCl, which look at the first problem that we did, right? AgCl is insoluble. So what's going to happen to the concentration of my silver ions?
Go down.
It's going to go down. So if I drop the concentration of my silver ions, okay, what's going to happen to the value of E?
It's gonna decrease.
And it's going to go up. Danae's saying it's going to go down.
Because silver ions are on the bottom, so is that molarity, or is that concentration decreases?
Well, there's a couple ways you can look at this, right? If I drop the concentration of my silver ions,
Q increases.
Q is going to get bigger, so therefore E is going to become
Smaller.
smaller. So mathematically, that's how it works. The other way you can look at it in terms of a party, you're going to have fewer silver ions over there going, hey, electrons, come over here. We got big party going on. We got Chex Mix. It's a good time. Okay.
Actually, it doesn't sound too bad.
I don't know.
Rye
Chex
chips.
Mix. Okay. I'm just saying. Maybe it's got just the Gordito rye chips. I don't know. Okay. But anyway,
I'll be
but
there.
the point being is that there's not going to be as many silver ions pulling those electrons. So conceptually, if you like that idea, you can go, okay, hey, there's going to be less potential for that to happen. Okay. So there's that. Make sure that if I give you like a certain number of moles and a certain number of moles that you can figure out like the empirical formula. Okay. So if you're fuzzy on that, make sure that you can do that.
I'm very fuzzy.
Well, I'm just getting unfuzzy between now and then. So let's say that you had something like this, where you had, I don't know, 2H2 plus O2 yields 2 waters. And let's say that you've got 4 moles of hydrogen and you have 6 moles of oxygen. How many moles of water can you produce from that? So first off, is this a limiting reactant problem?
Yes.
Yeah.
Excuse me. How do you know? It is a limiting reactant problem, but how do you know?
You told us the amount of each substance.
Yeah, if I just said, hey, you have 4 moles of hydrogen, how much water can you produce? You're just assuming that you have enough oxygen to make it happen, okay? So since you're given information about both, you have to convert them both into water. Now, can we use M1V1 equals M2V2?
What?
I mean,
Theoretically.
yes.
We could with the hydrogen and the
And the water.
water, because they are in a,
1-to-1.
so if I've got 4 moles of hydrogen, that's going to produce 4 moles of water. So the 4 moles of hydrogen is capable of producing 4 moles of water. Everybody cool with that? It's just a 1-to-1 ratio. That's what we took advantage of above when we worked this first problem. Now, if I've got 6 moles of oxygen though, for every 1 mole of oxygen, that's going to produce 2 moles of water, which is going to get me, so the 4 moles of hydrogen can produce 4 moles of water. The 6 moles of oxygen can produce 12 moles of water. So how much am I going to make?
4 moles.
4.
The smallest amount.
You forgot to multiply the 4 by 5 and then divide it.
Huh?
You forgot to multiply the 4 by 5 and then divide it by 5? You forgot-
I did it up here.
Oh, okay.
I'm old school. I can do that in my head.
Yeah.
Multiply by 5. divide by
Wait,
5.
so if you can do it in your head, why can't we do it?
Well, he's gotta make sure that we're multiplying by 5
And then dividing by 5.
Correct.
Yeah.
Can I subtract 5 if I
Yeah.
want?
You can subtract, well, no.
Okay.
No. That's not how this works.
Do it if I want.
Anyway, so those are the big things. So I'm done.
Okay.
Oh, you were.
So let me hand out the review. Now you have all of your old tests. I'll tell you right now, don't worry, I'm not going to make you like write out the 7 strong acids and their formulas. Okay, would you need to know them? Because I don't want you to
Probably.
be on the test going, hey, Brooke, what's the Ka of hydrofluoric acid? Okay?
Just smack
And then
that
I will have to
person.
mercifully, yeah, go just stop. At that point, I'm just gonna take the test away from you and